Welcome to the second of 4 videos concerned with the laws of logarithms. It's important that you view all of these videos and in order so that the explanations will make sense. It's also important to note that you can download the resource that corresponds to these videos from the Nassau website. If you want to learn more about that free resource, just search up free math resources on YouTube. With example 3, we're asked to solve the logarithmic equation x is equal to log base 3 of 27 subtract 2 log base 3 of 3 plus log base 3 of 1/3 using 2 different methods. Now it's important to note that this question's been cooked so that you can solve it using 2 different ways based on the limited knowledge you have at this time regarding logarithms. Now the first method I'm going to use involves using the law of logs, and I can use my laws of logs in this case because all 3 of these logarithms have the same base of 3. I've started by using my third law of logs and changing the 2 log base 3 of 3 to a log base 3 of 3 squared. Remember that with the third law of logs, a coefficient of a logarithm can be expressed as the exponent of the argument, and that's what I've done here. The log base 3 of 3 squared can now be expressed as log base 3 of 9. I'm now going to use my first and second laws of logs to further simplify this logarithmic equation. My second law of logs states that when I subtract logarithms with the same base, as is the case with the first 2 logarithms that we have, the log base 3 of 27 subtract log base 3 of 9, we can express it as one logarithm in which the original arguments are now being divided. That's why we now have log base 3 of 27 divided by 9. The first law of logarithms states that when we add logarithms that have the same base, we merely multiply the arguments to create the new logarithm. Well, in this case, we're adding on the log base 3 of 1/3. That's why in the next step, you see the 27 divided by 9 being multiplied by that 1/3. So I've used 2 laws of logarithms in one step. When I complete the operations in the parentheses, I'm left with an argument of 1. Now I'll simply change the equation from logarithmic to exponential form such that it reads 3 to the x equals 1. So x must equal 0. Now the second method we're going to use involves evaluating each logarithm separately and worrying about the subtraction or addition afterwards. So I'm going to start by evaluating log base 3 of 27. If I let a equal log base 3 of 27, then the question can be changed to its exponential form of 3 to the a is equal to 27. In that case, a would have to be equal to 3 because 3 to the 3 is equal to 27. Therefore, log base 3 of 27 is equal to 3. Next, I'm going to look at log base 3 of 3. If I make that equal to b, then my question becomes in its exponential form, 3 to the b is equal to 3, and therefore b must be equal to 1. So we can now conclude that log base 3 of 3 is 1. And finally, we're going to evaluate log base 3 of 1/3. If we say that that logarithmic expression is equal to c, then when I change it to its exponential form, it would be 3 to the c is equal to 1/3, and therefore c would have to be equal to -1. So we can conclude that log base 3 of 1/3 is equal to -1. So let's substitute these 3 values into our equation. As we said, log base 3 of 27 is equal to 3, log base 3 of 3 is equal to 1, and log base 3 of 1/3 is equal to -1. Now we simply have to do the multiplication, subtraction, and addition to work out our answer for x. And when we do so, we find that x is equal to 0, the same answer we got when we used the first method involving the laws of logs. With the next question, we're given the function y equals 2 raised to the x, and we're asked to find x when y equals 9. So we're going to start by writing down our function y equals 2 raised to the x, and we're going to substitute 9 into the equation for y. Now up to this point, the only strategy we know for solving equations such as these is to convert everything to the same base. But that strategy doesn't work here, so what do? Well, this is the whole point about learning about logarithms and the laws of logarithms, so we can tackle questions like this. What we're going to do is log base 10 both sides of this equation. The only reason I chose log base 10 was our calculator works with log base 10. Now what we're going to do is use one of our laws of logarithms, specifically the third law, where you can take the exponent of the argument and express it as the coefficient of our logarithms. That's how we were able to change log base 10 of 2 raised to the x to x log base 10 of 2. So remember, I want to solve for x. So how am I going to do that? I need to isolate that x on the right-hand side of the equation. I can do this by dividing both sides of the equation by log base 10 of 2. When I do so, I find that x is equal to log base 10 of 9 divided by log base 10 of 2. I can now use my calculator to evaluate these two logarithms. The log base 10 of 9 is equal to 0.954, and log base 10 of 2 is equal to 0.301. I simply do the division and I find that x is equal to 3.170. Now you should ask yourself, is this answer reasonable? Well, remember, we're trying to solve the equation 9 is equal to 2 raised to the x. Well, we know that 2 raised to the 3 gives us 8, and 2 raised to the 4 gives us 16. Therefore, it seems pretty reasonable that 2 raised to a number somewhere between 3 and 4, closer to 3, would give us the answer 9. So I'm very comfortable with the answer that x is equal to 3.17. You could check this answer by simply taking our calculator and taking 2 and raising it to the 3.170 and find that it's approximately equal to 9.